Welcome back to Mastering C++ 20 Features. In the last lecture, we glanced through the CPP reference page on concept and saw the various ways in which requires keyword could be used. The two major categories of usage being the requires clause and requires expression. Later in the lecture, we used the requires clause with the type trait expressions which were of constant compile time expressions and whose results were Boolean and hence were used as compile time predicates for constraining the template parameters. In this lecture, we'll understand what constraining template parameter means, and later we will take a closer look on the requires clause that we used in the last lecture. To constrain the template parameters, we need to have compile time predicates. In the last lecture, we used type traits as our compile time predicates. The predicates are used by the compiler to generate code on a given type. If the predicate is true, then the code is generated, else the compiler can either look for a different overload or abort. Constraining the template parameters has the following usage. Better communication on the requirements on template types by reading the code. Compared to sFine and type traits, they are much easier to read. And moreover, if the compilation fails, we have a much more readable compiler warning. Lastly, constraining the template parameter forces the compiler to generate different code for different types. Compiler-generated code has no runtime performance penalty, works the same or better than hand-typed code, and constraints are only applied during compilation and have no effect on how the program behaves during execution. Now let's talk more about the requires clause that we used in the last lecture. Requires keyword was introduced in C++ 20 to apply constraints to generic code. Requires clause looked like this. We had the template type name T, followed by requires clause and some constant expression. In our case, the constant expression was a type trait constant expression, and then the function declaration or definition. The requires keyword appearing before the constant expression is the requires clause that we are talking about. The requires keyword is followed by a constant Boolean expression, and the constant Boolean expression must evaluate to a true or false. That is, it should be a predicate and should be compilable or evaluatable during compile time. std arithmetic v is a combination of type traits of both of these types. Now let's talk about the usage of requires clause. In the last lecture, we already used the requires clause before the function declaration, like below. That is, the requires clause was between template type name T and the function declaration. Another requires clause usage could be after the function declaration and before the definition. This is called a trailing requires clause. It looks like this. The requires clause comes after the function parameter, but before the function definition. The advantage of using trailing requires clause is that we can also use the function parameter instead of the template type, like here. By the way, if you noticed, I'm not using std is floating point v or is integral v. I'm using std is arithmetic v, which is a combination of std floating point v and is integral v. If you want to see the CPP reference page on the type trait std is arithmetic v, you can notice that a possible implementation of std is arithmetic is using both of them with an Boolean OR. And next we will look at the requires expression in the next section with some code examples in the same add1 method. So stay tuned and enjoy learning modern C++. Hello there. If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website, mastering-modern-cpp-features.thinkific.com. Thank you.